Assalamu alaikum dear student, this is Wajid Lisha, and in this video lecture we are going to discuss magnetic field due to solenoid, which is given on page number 119. What is a solenoid? Any conducting wire wounded in the form of a spring or in spiral shape. As shown in the diagram. For example, this is a conducting wire in the form of a spring, a battery connected to the spring, positive potential, negative. Battery, this is a spring. So, as we know that current will start flowing starting from the positive terminal of the battery and moving towards the negative terminal of the battery. And because of that current, a magnetic field will be produced like this. This one. This is north side of the magnetic field, this will be south. According to right hand rule, we can find the same direction by the use of right hand rule. What is right hand rule? Extend the fingers in direction of the current, the thumb will give you direction of the north side. So, this is current flowing like this, out of the board and in this part into the board, out of the board 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 into the board. Out of the board direction is shown by the dot encircled, and into the board direction is shown by cross encircled. These are conventions for showing the direction into the board and out of the board. Cross into and dot out of. So we can use this concept, like this is called right hand rule. Curl. Keep your fingers in the direction of the current out of the board. The thumb will give a direction of north side. Right hand rule. What is the function of solenoid? Solenoid is used basically in electrical circuits to produce a magnetic field very much same as that of a bar magnet. So this is a solenoid. In order to find the magnitude of the magnetic field of the solenoid, we can use it like a solenoid. Like this, positive and negative. The current is moving out of the board in this loop, into the board in this loop, out of the board here, into the board here. So we can show dot and cross down. Okay. Cross shows that the direction of the current is into the board at down level and out of the board at the top. We can take an imperial loop to find the magnetic field of this solenoid. An imperial loop is taken like this. This side is taken L1, this is L2, this is L3, this is L4. Magnetic field is horizontal like this. This is north, this is south. So by the use of Ampere's law, we can write sum of all the products of the magnetic field by the length segment of the Amperian loop, this is mu naught, and the total current enclosed. We need actually to calculate this portion and put it here. This is equation 1. We can write the total sum of the magnetic field and length product is B1 L1 plus B2 L2 plus B3 L3 plus B4 L4. Okay. As sum of the total dot products of the lengths, you can take it as capital or small, it's up to you. Okay, so B1 L1, as it is a dot product, so we can write it a dot product. B1 L1, B1 dot L1 is equal to B1 L1 cos of theta. So angle here is 0. The angle between length and the magnetic field is 0 here. So we can write simply B1 L1 plus the angle between magnetic field and the length is 90. So we can write B2 L2 cos of 90, which is equal to 0. Similarly, B3 L3, B3 is this one. L3 is there, but we can see that there is no magnetic field in this area, so B is equal to 0. Because of this term, we can write 0 instead of B3 L3. Again, B4 dot L4, B4 L4 cos of theta 4. Again, magnetic field is to the right, length is down. So again, there is 90 angle with each other, so we can write again cos of 90 equal to 0. So we can simply write BL as sum of all the dot product of the individual components. So put it in equation 1. This is equation 1. We can write BL is equal to mu naught. The total current enclosed, as this is a solenoid, so it must be having n number of turns, n number of loops. So n number of loops multiplied by the total current. So we can write Ni is the total current of the solenoid. Ni is the total current of the solenoid. Because current I is flowing through each loop, the total number of loops is n. We can write the total current enclosed as Ni. Or we can write B is equal to mu naught capital N divided by L, like this, small l, because it is a small l. Okay, so total current L. Or we can finally write magnetic field of a solenoid is mu naught small n capital N divided by small n, so I. This is magnetic field produced by a solenoid. Thank you. Have a nice day.